All right. Good afternoon, Jonathan, Anna, Nerissa, and Rezi. Okay. So, medyo meron akong bubo kaninang umaga. So, actually, kagabi pa, I scheduled an email for everyone by Canvas announcements that the problem set number one will be live by 8 a.m. Tapos, ginawa ko na rin siya kay Canvas. Nilagay ko, okay, make the problem set questionnaire available to everyone by 8 a.m. this morning. But the boo-boo I did was I forgot, or actually I didn't did. Damn. No, I didn't do is to publish the module kung saan sorry, napindot ko naman yung mute button. Anyway, so the boo-boo I did ay hindi ko pala nagawa ay hindi ko na-upload yung module that is supposed to contain problem set number one. So it's just around during the class na kanina, just sa unang 155 at around 11:30 ko na-publish yung module. So but hopefully by now you guys have or can access the first problem set. Siguro maybe I'll give you a couple of actually emphasize ko lang yung ilang parts nung instruction. Okay, so download the questionnaire from the modules tab of Canvas. Nandun sa problem set 1 ng module. Tapos nandun din yung links para dun sa submission sa bawat problem. For those who are my new students, so never ko pa naging estudyante before, I usually ask students to submit problem set separately. So meron tayong anim na numbered problems sa problem set number 1. So bawat isang numbered problem ay merong individual submission bin. The purpose of that is for you to be able to submit one numbered item at a time, para hindi nyo naantayin na matapos yung sagutan lahat ng required sagutan bago kayo makapag-submit. So once you're done with, say, problem number 1, upload it for the submission bin, problem set 1.1. If you're done with problem number 4, submit it to PS 1.4. Okay? So para medyo nababawasan yung ginagawa nyo. Alright? And then at the same time, I can also start grading yung mga pumapasok na submissions. So I usually do that whenever I have a free time or if I don't want to do anything, sinisimula ko ng mag-check kahit hindi pa due. So, ganun ko siya ginagawa. And it will be great to have your answers ahead of time, especially if you're already sure na final na yung answer nyo. Okay. Now, the content of problem set number 1, may mahabang instructions dyan. Pakibasa na lang. The most important thing probably is that the deadline is on the 23rd of March. That's going to be on Wednesday, right before midnight. Okay. And then there are 6 numbered items in the problem set, but you're only required to answer 4. Apat lang yung sasagutan nyo. Okay. Ano-ano yung mga sasagutan nyo? Well, number 1 is required. So, simulan nyo na sagutan si number 1. Kahit after ng klase natin, I think you can answer problem number 1 right away. Required yung number 1. And then you need to choose 3 more problems from the remaining 5. The only restriction is that you can only choose at most 1 between numbers 4 and 5. Okay? So, isa lang kay number 4 at number 5 yung pwede nyong piliin. Pwedeng wala kayong pilihan sa kanila, pero hindi pwedeng piliin nyo ng sabay si problems 4 and 5. Okay? Ano ba yung problems 4 and 5? Problem number 4 is an example building problem. So, meron ako dyang 4 na descriptions. Sa bawat description, kailangan yung magbigay ng isang set E na nakakasatisfy ng description na yon. So, for instance, in 4A, kailangan makapagbigay kayo sa akin ng isang set E na ang derived set is equal to pi E 22/7 at saka E squared. No proofs required, no explanations needed. So magbigay lang kayo, set E equals this guy. Then that's it. No other requirement. Wala akong hahanaping explanation, wala akong proof na hahanapin. Okay? So, by the way guys, nag-move ba yung screen ko? Na-stuck siya sa instructions. Kaya siguro may nagli-leave at nagre-rejoin. Na-stuck ba siya?
Nasa instructions po siya sa akin, sir.
All right. So, hold on. Restart ko yung sharing. Okay. So, walang explanations na needed dun sa problem na yon. So, pakita ko lang yung actual problem. Okay, there you go. So, halimbawa sa problem 4A, magbigay lang kayo sa akin ng isang set. Tapos i-check ko ang derived set ba nung binigay yung set ay pi e22/7 at saka e squared. So, wala akong hanaping explanation. And because of that, the problems under number 4 would be all or nothing. So 2.5 points each, okay? Tapos yun, pag mali or pag merong kulang, 0 na kagad yun. So it's sort of a double-edged sword. So kaya medyo baka ayaw nyo ng number 4 kasi all or nothing nga siya. And then say for part B, iba na yung condition B. Yung condition B, hindi na kailangan satisfy ni E yung property A. Okay? So, independent yung mga answers na yan. So, 4 na sets. Tapos yung set yung ibibigay na satisfy yung nandun sa number kung saan nyo siya gustong maging example. Okay? Now, problem number 5 on the other hand, siguro maraming sasagot dito. True or false? Okay? No explanations or proofs needed. Actually, I ultimately decided to create a Canvas quiz para sa number 5. So, pag pinunta niyo yung PS 1.5, meron lang dong meron dong 6 na fields, sasagutin nyo lang kung true or false. Wala na talagang explanation. Click-click nyo lang yung true, i-click-click nyo lang yung false. And then once you hit submit, makikita nyo na yung mga sagot, yung explanation ko kung bakit ganun yung sagot, at saka yung score nyo. So, again, this is all or nothing per item, okay? So, pati, ganun din yung 4, all or nothing per item, okay? So, this is worth 10 points. Bawat isang problem ay worth 10 points. So, paki-check na lang kay Canvas kung paano ko dinistribute yung 10 points among the 6 problems. Merong mga worth 1.5, tapos may mga worth 2 points dun sa problem number 5. Okay? So, yon, isa lang kay 4 at saka 5 yung pwede nyo sagutan. Pero kung nanghihinayang kayo na all or nothing per item, then, o kaya dahil paborito nyo mag-prove, and then sagutan nyo na lang yung problems 2, 3, and 6. Pwede rin naman yan. Pwedeng wala kayong piliin between 4 and 5. Pero ang usapan at most one between 4 and 5 lang yung pwede nyo isubmit. And then do not attempt to submit more than 4 problems because I will just ignore the last problem that you submitted. If you had too much time and you really love Math 155, which is good for you, all right, at gusto niyo sagutan yung dalawa pang natitira, then that's fine. Pero wag niyo nang isubmit kay Canvas. I-send niyo na lang siya sa akin via email para alam ko kung para gradean ko siya or para mag-comment ako dun sa work niyo, alright? Pero wag na kay Canvas kasi magugulo yung sistema ko, alright? At saka mau-OC lang ako na merong something for grading dun sa column na dapat naman di ko na kayo gradean, okay? I-ignore ko lang talaga yung huling dalawa yung isa-submit, okay? So yung unang 4 siya lang yung ika-count ko. Alright, so any questions? So since this is already available, I believe you can answer siguro item 4, item 5, or item 1. Siguro today, pag wala na kayong ginagawa ngayong araw na to habang nagpapahinga, pwede nyo gawin yan. So you have Thursday, Friday, Monday, Tuesday, and Wednesday. So you have 5 days to answer 4 problems. So kung ayaw nyo ngayong mag-work, start kayo bukas, 1 problem a day. You are still on track. And that could even be lighter if you will include the weekends. Pero kung feel nyo mag-chill tuwing weekends, then that's also fine. I also do that. So, wag kayo mag ng weekend, pero yun nga, 1 problem a day, you're still good. Okay? Now, I suggest is at least you read the problems. Kasi pag binasa nyo yung tanong, I believe our subconscious is starting to think of ways on how to solve these problems, all right? So kahit mag-relax kayo over the weekend, why not let the ideas ferment on your minds? And probably pag punta nyo ng Monday, mabigla na lang kayo, meron kayong biglang maiisip, right? So because I think that's one peculiar thing. I don't know if superstition ko lang to or kung ano yung scientific basis. Pero halimbawa, nag-work ako ng isang problem, meron akong homework, tapos ilang oras ko na siyang inupuan, hindi ko talaga siya ma-solve. Gagawin ko, close ko muna yung lahat ng work materials ko, mag-open ako ng Dota, tapos maglalaro ako for 1 or 2 games, o kaya magne-Netflix, tapos maglalakad-lakad. I'll completely forget about the frustration I have with a certain problem. And then when I go back and sit down on it, parang alam ko na yung mangyari, or I have an idea paano siya sasagutan out of the blue, but I believe my subconscious is doing something, all right? Na parang sa kanya lang ipapasa sa aking conscious mind yung naisip niya. Or meron din ba kayong experience na habang nagsha-shower, bigla kayong may maisip, baka ganito yung pwede kong gawin sa thesis ko, o pwede kong gawin din sa problem set. I don't know, but that happened to me multiple times. And I guess kapag pigang-pigan na talaga ako, I'll need to stop, recalibrate, relax, and try to refresh myself, and then start working again when I think I'm ready. So wag niyo masyadong damdamin, lalo na kung math, because I think if it's a math problem, it really needs fermentation sa ating mga utak. All right? So any questions on the surface about problem set number 1? Because I think ito na yung huling time nating mag-meet. Meron pa naman Tuesday, pero by Tuesday, medyo ano na kayo nun, medyo nagpa-finalize na lang kayo ng answers, right? So let me know if you have some questions. I'll try to answer as soon as I can. Okay, kasi mag-weekend na. Pero may Friday pa naman. So if you have some questions, kung meron kayong text na hindi maintindihan, kasi medyo old school ako, gusto ko nakasulat. Kung pwede nga lang yung lecture notes ay handwritten na lang, pero prepared na naman siya. But I love writing things kasi mas mabilis nga siya. That's my personal touch. So if you cannot understand anything here, I write in cursive. So paki-email na lang ako kung merong hindi klaro. Okay? So that's it. Problem set number 1. Good luck, guys. Happy solving. And sabihan nyo na lang ako ng mga reklamo nyo on Tuesday. All right? I hope kaya siya. In-imagine ko yung mga solution. Mukha naman kaya siya. Alright? Mukha naman. At ako na to, mabagal talaga ako mag-solve ng mga math problems. So, yeah. If I think I can do it in 1 hour, probably you can do it in less. So, yeah. Okay. So last Tuesday, we were able to finish unit number 1. So we're ready for a brand new chapter in Math 155. And actually, this chapter is nothing new. And it's a good thing because you are probably now preoccupied and thinking about problem set number 1. So ngayon, medyo light lang siguro yung lecture. Hindi ko kayo bobombahin ng sobrang daming concepts. Posibleng maraming concepts, but these are nothing new for you. Lalo na yung mga kaka-math 38 pa lang. Sino ba dito yung mga katatapos pa lang ng 38? Or doon ba sila nag-cluster sa kabilang section? Kasi I have lots of my Math 101 students from last semester who decided to take 155 right away. Diba usually 1 year after pa ng 101 ng 155. But yun. So ibig sabihin matatanda na kayo. Luma na yung Math 38 sa inyo. But we'll be talking about sequences of real numbers today, which is basically what you started, what you discussed in Math 38. Though it will seem like a review because kung ano naman yung sequences sa Math 38, yun din naman yung konsepto ng sequences sa Math 155. The only thing is that we will go beyond computations or finding limits of sequences, but digging in at properties of sequences, their limits, convergence, and divergence of sequences. Okay? Tas medyo kakaiba yung approach sa 155. Kasi sa 30 series, nagsimula tayo sa functions. Alright? Nag-compute kayo ng limit ng functions sa 36, tapos nag-integrate sa 37, tapos sa Math 38, nag-discuss na kayo ng sequences. Tapos ang pagkaka-benta sa atin ng sequences, sila isang special case lang ng functions. Because they are functions whose domain is the set of natural numbers. So lahat ng yung konsepto ng limit ng isang sequence ay itatali natin pabalik dun sa konsepto ng limit ng isang function. Do medyo kakaiba kasi discrete yung sequences, all right? So defined lang siya sa mga natural numbers, unlike yung functions sa Math 36 na subsets ni R or intervals at least yung kanyang domain. Okay? Pero ang sinabi natin, because of a nice property of functions, okay, na parang kapag ka nakakuha ka ng counterpart ng sequence, pag pinalitan mo yung variable doon sa sequence at pinayayagan mo na yung domain ay ma-enlarge para ma-encompass yung buong real numbers. So parang yung limit nung sequence mo, yung nung original sequence mo ay equal lang dun sa limit nung function nung function over the set of real numbers na extension niya. So parang nakatali dun sa konsepto ng limit ng isang function, yung konsepto natin ng limit ng sequences. All right? Of course, that is if really we can have an extension. Pag kaya nating extend yung domain ng sequence. Pero dito kakaiba, baliktad yung gagawin natin. Kasi parang mas simple yung function, yung sequences. Kasi siya ay function ng domain lamang ay natural numbers. You can even throw away the concept of it being a function. Isipin mo lang siya as an ordered list of real numbers. Okay? Tapos pag kinuha mo yung limit niyan, okay? Essentially what we're doing when taking the limit of a sequence, we're looking at the behavior of the sequence at the tail end. Titingnan natin ano yung nangyayari dun sa dulo ng listahan habang lumalaki yung subscript or habang tinitingnan natin yung value kapag ka malalaki na yung n. Yung tinitingnan natin as a limit. So basically, mas simple siya kaysa dun sa limit ng isang function. So ganun yung gagawin natin sa Math 155. In this unit, we'll talk about sequences, investigate the convergence of these sequences, and look at the properties of their limits. And then when we go to unit number 3, limits of a function, we will we will actually define the limit of a function using limits of sequences. So ipagtataliin natin silang dalawa. And because of that, because there is a way of characterizing the limit of a function through the limit of equivalent or actually associated sequences, okay? Yung mga properties na ma-prove natin ngayon for sequences ay sila yung magpapadali nung pag-prove natin nung mga concepts about limits of a function. So nakita niyo yung parang kabaligtaran. Ano yung paradigm sa Math 155? Kasi nga axiomatic tayo. Gusto natin mag-start dun sa mga mas simple and then start generalizing it to the more complicated concept hanggang buo natin uli yung konsepto ng calculus na meron tayo sa Math 30 series. Okay? So that's the plan for today. So I hope you guys have a copy of Unit 2 lecture notes right now. So nandun siya sa link natin. May isa pa wala akong announcement na nakalimutan ko. I already have my consultation hours. It's 9 to 11, Monday to Friday. Okay. So in our Canvas webpage, you can see there yung team code para sa MS Teams for my online office. So that's what I'll use for online consultations. I'll be around 9 to 11, Monday to Friday. I will not open the meeting link for my consultation. Pero online ako nun, i-chat nyo lang ako sa Teams or send me an email para sabihin ako na, sir, may ko-consult po ako. Tapos saka ako bubuksan yung meeting sa online office. Alright? Para lang makatipid ako sa bandwidth. Alright? Hindi ko siya bubuksan. Pero nag-aantay ako. I'm online at the back end. Just let me know 9 to 11, Monday to Friday, if you want to meet. Okay? And also, I'm thinking about putting up reels or short videos. Kung meron kayong mga tanong via email, tapos medyo matrabaho siyang sagutin via email, I'm thinking about instead of painstakingly write a long email to you, maybe I can record a short video, 30 seconds or a minute video, and then send it to you or upload it into my YouTube channel and then also in Canvas para nandun yung explanation at para makita rin ng iba, right? Para nakita ko nga, unti-unti na kami nagiging vloggers dito, right? So, kasi nga, we have to adapt with the technology or the situation that we have, right? Speaking of, kailangan ko na mag-isip ng closing spiel. Naluluma na yung spiel ko. Lagi na lang yung sinasabi ko. Nabubulol ako kasi nag-iisip ako ng bagong sasabihin. Pero I always end up saying the same script over and over again. So kung may suggestion kayo, padala nyo rin sa akin via email, alright? Now, if you're not available during my consultation hours, then just send me an email, probably a day or two in advance, and then let's try to see if I can meet you. All right? Tingnan natin kung magsiswak yung schedule natin. Excuse me. Alright. So ito yung, alright, back to Unit 2. Ito yung outline ng Unit number 2. Probably let's try to do 2.1 today, defining what the limit of a sequence is. Okay? Para medyo light lang. Alam nyo na to. So kailangan lang nating i-recall, tapos konting proving lang about limits of sequences, and then let's call it a day para masimulan nyo ng basahin yung problem set number 1. Okay. So let's start with the basics. So definition 1. What is the sequence? Actually, what is a sequence? So ano ang isang sequence? Well, definition 1 tells us that it is just a function whose domain is the set of natural numbers and codomain is a set of real numbers. So ibig sabihin, a sequence is a rule that assigns to every natural number a unique real number. So pag binigyan kita ng isang natural number, yung sequence mo magbibigay sa akin pabalik ng isang real number. Okay? So ang domain niya ay N, codomain ay R. So basically, we write it formally this way. So ito ay, ibig sabihin ito, F is a function whose domain is a set of natural numbers and codomain is the set of real numbers in such a way that the natural number N is assigned to the value A sub N. So basically, A sub N is the image of the natural number N in this function or in this sequence. Okay? Now, we can also write A sub N equals F of N para ma-emphasize yung pagiging image ni N, pagiging image ni A sub N ni N under the function F. And we also call this as the nth term of the sequence. Ito yung peculiarity ng sequence mula sa function whose domain is R. Kasi rito, kaya nating, there's an efficient way of listing down the elements of N, and that translates to an efficient way of writing down the element or the function values of or the function values in the sequence. Kaya pwede natin silang pangalan ng first term of the sequence to refer to f of 1. Second term of the sequence is f of 2. Third term in the sequence is f of 3 or a sub 3, and so on. So kaya natin silang ilista. Okay? So pwedeng f of 1, f of 2, f of 3, and so on. So that's another way of writing a sequence. Of course, we can write an assignment, okay? We can write the formula. How can we compute a sub n if we know the value of n? But another way is to list down the elements of the sequence, or at least the first few elements of the sequence. This is something that we cannot do with functions whose domain is R. Walang efficient way na masusulat natin sila. Though pwede mong isulat yung ilang mga function values, pero ang kagandahan dito, may certain order. Na kapag ka nakita natin yung listahan, alam ko na yung una sa listahan na yon, siya si f of 1. Yung pangalawa, that's the second term in the sequence. That's the image of 2 under the rule f, and so on. Okay? So basically, that's the first way of describing a sequence. Okay? Isulat siya as an ordered list. Okay? So this is different from the notion of a set. Diba sa set, ordering doesn't matter. Pero kapag clear in context na yung naka-brace ay isang sequence at hindi lamang basta-basta isang set, ibig sabihin yung order niya nagma-matter. In such a thing, in such a way that this sequence 1, 1/2, 1/3, 1/4 is different from the sequence 1/2, 1, 1/3, and 1/4. Okay? Can somebody help me explaining bakit hindi equal yung dalawa na yan as sequences? So if these two guys are treated as sets, then equal sila. Pero in our discussion, it is clear that they stand for sequences. Okay? Bakit hindi equal yung dalawang sequences na yan? Or yung dalawang ordered list na yan? Kasi wala naman akong ginawang fancy. Pinagpalit ko lang yung first at saka second terms. So bakit sila hindi equal as sequences? Okay, Charles is correct. Magkaiba yung f of 1 and f of 2. Remember, kapag ka nakakita kayo ng isang list and it is clear in the context that that list is a sequence, okay? Ibig sabihin, the first term the first number in the list is f of 1. Okay? Pag tiningnan mo yung kabilang listahan, f of 1. Okay? So ang problema, f of 1 on the left sequence is 1, while on the right sequence, it is 1/2. So definitely magkaiba silang dalawa. All right? So though there is an abuse of notation here, parehas yung notation natin para sa set at saka sa sequence, all right? But whenever clear in context, nagmamatter yung order kapag ka nag-uusap tayo about sequences. All right? Now, yeah, that's the first way, listing down the first few elements. This might be helpful, especially if we are trying to look at if we are trying to look out for a pattern. Okay. Pero another way is to write a distinguishing a distinguishing formula or a characterization of the terms in the sequence. So pwede rin namang formula yung isulat natin dyan. Ano yung formula para mahanap yung end term? Okay? So enclose the formula in braces. You can put the subscript n equals 1 and the superscript infinity. Actually, I also use this. Actually, I use this more often. 1 plus n over n lamang. Okay? Especially whenever it's clear in context that we're talking about sequences, then this guy will denote a sequence. Ano yung sequence na yan? Yan yung sequence ng nth term ay given by 1 plus n over n. Okay? And then if you want to get a listing of its elements, just plug in n equals 1, you get 2. Plug in n equals 2, you get 3 halves, and so on. Okay? So another way is to just enclose a sub n inside braces and put outside ano yung definition ni a sub n or how a sub n is supposed to be computed. Okay? And then there's another way. Actually, parehas lang yung 3 and 4 insofar as formats are concerned. But number 4 is a special kind of a sequence. It is a recursive sequence because we'll need previous values of previous terms in the sequence to get newer ones. Okay? May typo dito. Dapat yung plus 1 naka-subscript. So in particular, in this example, para ma-compute, given ang x sub 1 ay equal kay 2, all right? Pero para ma-compute yung x sub n plus 1s for n greater than or equal to 1, kailangan mo yung previous value, dadagdagan mo ng 1, tapos i-divide mo by 2. So dun sa mga nag-175 dyan ngayon, para siyang yung iterative process. Kailangan mo yung previous values para makuha yung susunod na element ng sequence. Yeah, actually, yung mga sequence na binubuo natin sa Math 175, sequence of estimates, yun ay mga sequences din. Alright? Tapos sinitingnan natin saan siya nagko-converge. Yun nga lang ang hope natin, dinesign natin yung recursive formula para dun sa mga sequence na yun so that it will converge to a desired number. So 155 mas general kasi nauna yung listahan, nauna yung formula, titingnan natin saan siya nagko-converge kung nagko-converge man siya. Okay? Mas malaki pa yung ginagawa natin sa 175, no? Kasi dito, convergence lang. Malaman lang natin na nagko-converge siya. So 175, tinitingnan din namin gaano kabilis siya nagko-converge dun sa limit ng sequence na yun. Okay? Essentially, that's it. Siguro, tingnan natin paano nakukuha yung first few elements dun sa pang-apat. Alright? Initial condition, x sub 1 equals 2. So that's our first term in the sequence. To get the second term in the sequence, we simply plug in the previous term plus 1 divided by 2. All right? Gusto kasi yung n equals 2, so magkakaroon ng x sub 1 plus 1 ay equals to x sub 1 plus 1 all over 2. So this will give me x sub 2. All right? So x sub 2 would be what? Dadagdagan ko ng isa yung previous, so it's gonna be 3 halves. Tapos yung susunod ay x sub 2 plus 1. So that's going to be what? 5 halves divided by 2, 5 quarters, and so on. So, susunod naman ang x sub 4 ay 5 quarters plus 1 divided by 2. Mahina ako sa math, kayo na lang yung mag-compute nung natitira. All right? So, and so on. So, that's how we compute a recursive sequence. This reminds me of a very popular sequence. Have you guys heard of the Fibonacci sequence? So isa siyang example ng isang sequence na recursive yung definition. Show of hands, sino yung naka-encounter na? Siguro sa Math 20 nabanggit na to? Or even sa mga documentaries, Fibonacci sequences. So ito yung mga sequences na ang nth term ay sum ng mga two previous elements dun sa sequence. Okay? So, halimbawa, usual starting condition ay 1 at saka 1. Para makuha yung x3, pag-plus mo lang yung previous 2. So, you get 2. And then to get the fourth term, add the second and the third term. So we'll get 3. And then the next is 2 plus 3, we'll get 5. The next term is 3 plus 5, 8, and so on. Okay. This is another sequence, and actually this sequence arises in nature. Dun sa arrangement ng seeds sa sunflower and so many things. Okay. Present yung Fibonacci sequence, even in the way rabbits propagate. Meron ding Fibonacci sequence doon, or kaya siyang i-model using a Fibonacci sequence, all right? But one thing that we can observe with Fibonacci sequences ay palaki ng palaki yung mga terms, all right? And that's understandable because that's how the sequence is defined. We are adding two previous values to get the next term in the sequence. And we can imagine that as we go along in this process, palaki ng palaki yung mga terms. So pag mas malaki na yung term mo ngayon, mas lalaki pa siya dun sa susunod. Okay? And this is an example of what we call a monotonic sequence, but we'll talk about that later. Okay? So gusto ko lang ipakita yung iba't ibang paraan ng pagsusulat ng sequences. Okay. Now, we are not too much interested with just listing elements of a sequences, but we want to know what happens at the tail end of this sequence. Because the business of analysis is predicting what will happen as a certain condition is met. Pag nag-uusap tayo about sequences, titingnan natin ano yung nangyayari kapag ka lumalaki na yung subscript. Or if you have a listing of the elements or the terms in your sequence, ano yung nangyayari dun sa dulo ng listahan. We don't care too much about what happens in the beginning, but we're looking at the asymptotic behavior. Ano yung nangyayari habang lumalayo na ako sa listahan? Usually, we are interested whenever the terms of the sequence cluster around or accumulates a certain real number as the subscript increases. Gusto nating makita kung saan siya or saan pumupunta, saan nag-approach, saan lumalapit ng lumalapit, saan nagkukumpul-kumpulan yung mga terms ng sequence habang palayo ako ng palayo dun sa listahan. Okay? Tapos yung number na yon, kung saan nagkukumpul-kumpulan yung mga terms ng sequence habang palayo kayo ng palayo sa listahan, ang tawag natin sa kanya ay yung limit ng sequence or the limit point of the sequence. Okay? And how do we define the limit of a sequence? That's what definition 2 is for. Okay? So we say that the limit of a sub n is equal to a as n approaches infinity. Okay? Or in other words, we can also say the sequence a sub n converges to a as n approaches infinity. Or simply you can say the sequence an converges. Automatic na alam natin n approaches infinity yon. Okay? Actually, I'm more fond of using this notation. A sub n approaches a, meaning the n term of your sequence converges to a if and only if the following statement is true. Ano yung criteria para masabi na nagko-converge yung sequence dun sa number a? Okay? Sabi nito ay sa kahit anong epsilon, for every epsilon greater than 0, however small it is, we should be able to find a capital N, a natural number capital N, such that for all little n's greater than that capital N, a sub n minus a is less than epsilon. Okay? Na medyo technical talaga yung definition, but let's try to understand what's happening in here. Bakit ganyan yung definition? Now, ano nga ba yung layman's interpretation ng limit? Diyan palapit ng palapit yung mga terms ng sequence habang palayo ako ng palayo sa listahan. So the bigger the subscript becomes, dapat palapit ako ng palapit dun sa number A. Yun yung ibig sabihin ng convergence. Nagkukumpul-kumpulan talaga sila sa A habang lumalayo ako sa listahan. But how can I guarantee or how can I explicitly say na sila ay nagkukumpul-kumpulan? Dapat sa kahit na nung epsilon na maliit, gaano man kaliit yung epsilon na yon, dapat may mahanap ka na starting capital N. So, di ba, ito si 1, 2, 3. Yan yung mga elements ng domain. 4, and so on. Dapat may makita kang capital N. Pag binigyan kita ng epsilon, yun yung challenge ko. Bibigyan ko kayo ng epsilon, bigyan nyo ako ng capital N. That's your response to my challenge. And what's the requirement for capital N? Dapat starting kay capital N hanggang sa dulo. So yun yung mga little n's na mas malaki kay capital N. Dapat yung distance ng nth term mula dun sa supposed limit ay less than epsilon. Okay? But again, epsilon is a very small number, so ibig sabihin, yung mga nasa dulo ng listahan, starting from capital N until forever, dapat yung nth term ay malapit na kay A, malapit in a sense na dapat yung distance nila ay less than epsilon. So in other words, if I give you a challenge epsilon, you should be able to give me a response capital N, such that any epsilon neighborhood around the supposed limit A ay magko-contain ng elements ni A sub n. Remember, this inequality here means A sub n is a member of the epsilon neighborhood of A. All right? So, ibig sabihin, starting, pag binigyan kita ng epsilon, kahit anong epsilon greater than 0, laging meron akong capital N na simula kay capital N hanggang sa dulo ng mga natural numbers, yung mga A sub n ay nagiging miyembro ng epsilon neighborhood ni little a. Okay? So palapit sila ng palapit kay capital A. So basically, that's what the technical definition of the limit of a sequence is. All right? Kailangan, oh, by the way, capital N, the choice of capital N might depend on epsilon. Okay? So kapag ka binigyan kita ng, halimbawa, epsilon equals 1, posibleng yung capital N mo, maliit lang na N. Okay? Pero pag niliitan ko na siya, halimbawa, epsilon equals 10 to the minus 6, usually yung capital N lumalaki na siya. Pero it doesn't matter kung 1 million yung capital N, 3 million yung capital N ang usapan, basta starting from capital N, going forward, yung A sub N ay super lapit na kay little a. Yun ay kung talagang limit ng sequence A sub n si real number A. All right. So that's it. But this is nothing new. I know you still remember it from Math 38. But any questions so far before we proceed? Oh, by the way pala, nag-gradean ko na yung homework 3. So kindly take a look at my my comments for homework number 3. Tapos, ang nakakatuwa lang ay nilagay ko na nga no proofs or no explanation needed. Ang dami pa rin nag-explain, ano. So, but I think that's a good habit, even if not required, nag-justify kayo. And for those who put justification, I also read your justifications, but I ignored it in grading. So, chinekan ko muna yung sagot nyo, tapos saka ko binasa yung explanation. Okay? So, kung merong may konting sabit yung explanation o merong mga language or semantics problem, kinorek ko siya. Pero hindi ko siya minusan kasi hindi naman talaga siya required. Okay? So, yon. Buti pa pala kapag sinabi na no explanation required nag-explain kayo, no? Pero pag proofs na, kulang-kulang na yung explanation nyo. Pero yeah, that's a good habit. Keep it up, alright? Yun nga lang, sa homework number 3, naging all or nothing siya. 0.8 point bawat isang problem sa sa problem number 1. Okay? Kasi 4 points yun, and then yung kumustahan question is worth 1 point. So over 5 talaga siya. Okay. So let's try to see this definition in action. Let's see how it is used. In this particular case, let's start with a very easy example. Let's examine the sequence 1 over n. Example 1 is telling us that the limit of 1 over n is equal to 0. Okay? Now, wala pa tayong tools paano mag-evaluate ng limit. Ito yung kabaligtaran sa Math 38. Kasi sa Math 38, meron ng Hitch theorem, marunong na kayong mag-evaluate ng limits ng functions. So pag yung 1 over n, pinalitan mo yung n ng variable x to denote the change of domain. Kasi pag 1 over n, understood sa atin, natural numbers yung domain. Pag pinalitan mo yan ng x, pwede mo nang imagine na ang domain ay real number. tapos kinuha mo yung limit ng 1 over x as x approaches infinity, napakarami ng theorem from Math 36 yung pwede niyong gamitin para makonclude na yung limit niya ay 0. Okay? But for Math 155, dahil wala pa tayong theorem, wala pa tayong Hitch theorem, wala pa yung theorems pag-evaluate ng limit, okay? Pag ganun, pwedeng intuitive analysis muna yung gawin nyo. Okay? Para magkaroon kayo ng hypothesis, ano kaya yung posibleng limit. Tapos saka natin siya i-prove. Fortunately for us, nalagay na kung ano yung limit, pero kunwari wala pa yung limit. Hindi pa natin alam na ang limit niya ay 0. Okay, one way to analyze this is to list down the first few elements of the sequence. Remember, we have the sequence 1 over n. Okay, kunin mo lang yung first few elements. So this is 1, 1/2, 1/3, 1/4, and so on. And here you can imagine, oo nga, no? Habang lumalaking subscript n, ibig sabihin, pumupunta na ako dun sa dulo ng listahan, okay? Lumalaki yung denominator, tapos lalaki yun ng lalaki without bounds. Tuloy lang yung paglaki ng denominator. Constant yung numerator, 1 divided by a later very, very huge number, okay? So mukhang ito talaga ay magko-converge kay 0. Okay? So note yung paggamit ko ng symbol, hindi ako nag-equal sign. Ang ginamit ko ay convergence. Alright? Kasi itong sequence na to, ang hula ko magko-converge siya kay 0. Or pwedeng tingnan mo na lang yung formula, 1 over n. What will happen to 1 over n? Lagyan ko to ng quotes. Pwede mong imagine magiging 1 over positive infinity yan. Okay? 1 divided by a very large number, we know that that will end up to become 0. Okay? Naka-quotes yan kasi baka awayin ako ng mga mathematicians, right? Kasi yung infinity, hindi naman yan number. We are not used to writing it this way. Pero yun yung idea, alright? So, pwede nyo kapain, pwedeng gumamit ng common sense. Tingnan lamang kung paano siya o kung saan siya magko-converge or saan pupunta yung ano yung mangyayari dun sa mga terms ng sequence habang palaki ng palaki si n. Alright? Well, another way, kapag komplikado naman masyado yung function, pwede niyong gawin ay i-graph. Okay? Tingnan yung graph ng sequence. Kaya lang be careful when you're presenting to me a graph in your solutions. Remember, ang sequence, ang domain niya lang ay n. So, ang ideal graph ng 1 over n equals 1, function value is 1. N equals 2, function value is 1/2. Nandiyan siya. 3 is 1/3, so it's somewhere here. 1/4, somewhere here, and so on. Tapos pag ginawa nyo ito ng paulit-ulit, graphically, palapit nga ng palapit sa y equals 0 yung mga dots. Okay? Pero pag komplikado yung function, you might be tempted to use a graphing calculator or a graphing software to see what happens to the sequence, all right? Pero pag pinasa nyo siya sa akin, tapos ang binigay nyo sa akin ay ito, kasi pinagraph nyo yung 1 over x. Without any explanation or caption, I will give you some deductions. Because if you will present this as if this is the graph of the sequence, then you will be wrong. Bakit mali? Bakit hindi ito yung graph ng sequence? Can anyone help me? Bakit pwede ko kayong minusan? Pagka walang explanation and it appeared from my mind that you are presenting this as if this is the graph of the sequence. Yes, Rezi? Alright, nagta-type siguro si Rezi. Yeah. Di po naka-extend sa kaliwa. Well, okay. Siguro ang ibig mo sabihin na hindi siya dapat naka-extend dun sa kaliwa. Naka-extend siya sa kaliwa so hindi siya pwedeng maging graph ng sequence, alright? So that's correct. And yeah, though I like the answer of Charles better, okay? Na yeah, hindi lang ang problema yung naka-extend siya dun sa kaliwa. Ang problema ay kahit dun sa pagitan ni 1 at saka ni 2. Alright? Sa pagitan ni 1 at saka si 2, ibig sabihin ito, may function value to. So dahil may function value to, yung katapat niya sa x-axis, ibig sabihin nagkaroon ng function value. Halimbawa ito si 1, yan si 1/2. Okay? So ibig sabihin kung ito yung i-present mo sa akin na graph, I will look at it and say, bakit mo binigyan ng function value si 1/2? Eh, ang usapan, sequence nga yung pinapagraph ko or pinapa-analyze ko sa inyo. So therefore, you are violating the fact that n is the domain of the sequence. Okay? So dapat mga natural numbers lang yung merong katapat na y value. So si 1/2, dahil hindi siya natural number, dapat wala siyang katapat na portion ng graph. Okay? But of course, mahirap magpa-plot ng sequences sa isang graphing software. Actually, madali rin din pala. Scatter plot yung tawag, yung gamitin nyo. Scatter plot kay MATLAB or kahit kay Excel. Meron kang scatter plot function doon. You can plot terms from your sequence there. Pero kung talagang meron ka lang ay graphing software, tapos ito lang yung kaya mong ipakita sa akin na part ng analysis mo, pwede mong siyang gamitin. Pero i-explain mo dun sa narrative mo or lagyan mo ng caption na, "Sir, this is the extension of the sequence in the sense that the domain was enlarged from the set of natural numbers to the set of real numbers." And basically, the behavior will be the same. All right? Titingnan mo lang yun yung behavior sa dulo. All right? Which is fine. Basta lagyan mo siya ng caption. Huwag mong ipresento sa akin as if this is the graph of the sequence. So you need to say something. Kung nga yung Instagram posts nyo, ang tagal yung pinag-iisipan ng caption, so bakit hindi yung picture na isi-send nyo sa akin as part of your academic work ay lagyan nyo rin ng magandang caption, di ba? So, yon. Kwentuhan nyo ako. Bigyan nyo ako ng captions. Alright? So, yon. And with this analysis, even if you look at this extension of the graph of the sequence to the graph of a function whose domain is R, okay? Makikita nyo na in the long run, palapit niya ng palapit sa x-axis. So ibig sabihin, mukhang yung mga terms ng sequence dun sa dulo ay palapit na ng palapit kay 0. And indeed, we will be able to prove in a second na ang limit talaga ng 1 over n ay equal kay 0. Okay? But how do we write a proof? Paano tayo nagsusulat ng proof? Well, the proof goes this way. You start with an epsilon greater than 0, an arbitrary epsilon, and we need to demonstrate the existence of a capital N. Mag-assume ako, let epsilon be greater than 0. It's a generic epsilon. And then with that generic epsilon, I should be able to give the reader a natural number n that might involve epsilon or that might depend on epsilon na mag-hold true itong inequality na ito. Okay? Mag-assume ka ng epsilon, tapos magbibigay ka ng capital N. Yun yung template ng proof. However, giving the capital N is not done in a flash. So hindi yan basta-basta lalabas. Hindi madaling maghanap ng capital N. That's why we usually start with the preliminary analysis, which is technically not part of the proof because medyo mandadaya tayo. Kailangan kong i-compute muna beforehand ano si capital N. We will look for a sufficient condition on capital N that might involve epsilon to guarantee na yung absolute value ng a sub n minus a ay magiging less than epsilon. Okay? Now let's look at how the preliminary analysis is written in the lecture notes. Okay. Now here we consider an epsilon greater than 0, and what we want to have is a natural number n such that kapag mas malaki na kay natural number n, yung mga subscripts little n, it follows that this inequality is true. Okay. So ito, we are working backwards. So parang pabaliktad. Mag-start ka dun sa gusto mo mangyari, tapos maghanap ka ng condition paano mo magagaranti yung gusto nating mangyari. Okay? So gusto ko ito ay maging totoo. So I look at this guy first. Okay? So I simplify ko muna yung a sub n minus a. In our case, that's easy. That's just 1 over n. Tapos ano bang alam ko kay little n? I don't want to deal with with little n. Ang hinahanap natin ay si capital N. The only relation that we have with little n and capital N ay yung little n ay greater than or equal to kay capital N. All right? But here, look at what I have. I am dealing with 1 over n after simplification. Okay? So dahil simplification, 1 over n, kailangan ko ay capital N. So I need to look at what is the behavior or what's the relation of 1 over little n with respect to something that involves capital N. Tapos babalikan ko, ano ba yung mga gusto ko or ano ba yung mga magiging assumptions ko dun sa proof. Part of the assumption is that little n ay sufficiently large. It is larger than or equal kay capital N. So from this inequality that will be part of the assumption in the proof, alam ko dyan ang 1 over n ay magiging less than 1 over capital N. All right? You simply divide both sides by little n times capital N. Makukuha mo itong inequality na ito. So 1 over n is less than or equal to 1 over capital N. Now, ano dapat, kunwari wala pa to, spoiler alert, okay, ano dapat yung behavior ni 1 over n para ito ay mapuwersa to be less than epsilon? So we are working backwards here. Kaya siguro kung binasa nyo to, hold on a minute, mapapaisip kayo, bakit nagkaroon ng 1 over n na singit sa gitna ni epsilon? Ganito siya ginawa, step by step. Sinimplify yung 1 over n minus a, nakita ito, kaya lang na-realize niya, hindi ko pala kailangan ng little n. Kailangan ko ay capital N. So, kailangan kong tingnan ano yung relasyon nito kay capital N. Ginamit ko yung magiging part ng assumption ng proof. Mula doon, nakita ko na yung 1 over n ay mas maliit kesa sa 1 over capital N. So, nasulat ko ito. Now, we are looking for a sufficient condition for capital N that might involve epsilon so that we can force 1 over n to be strictly smaller than epsilon. And one easy way to do that is to force the issue. So ito ay prepare sign ko to. We want to force the issue that 1 over capital N is less than epsilon. Okay? Kasi nga pag yung 1 over n ay naging less than kay epsilon, pero yung 1 over capital N ay greater than or equal sa 1 over little n, then 1 over little n will definitely be less than epsilon, which we desire. Okay? So ito yung magiging condition natin. We want to force 1 over capital N to be strictly less than epsilon. Okay? So isa na lang yung problema natin. Paano ko makakasigurado na so ito yung condition. Alam ko na mangyayari yung inequality dun sa definition kapag ka napuwersa ko yung 1 over capital N ay less than kay epsilon. So imagine what will happen in the proof. I will let epsilon be anything greater than 0. Then I say take capital N to be a natural number such that 1 over n ay less than kay epsilon. Okay? Pero bubutasan ko yung proof nyo. Yun yung trabaho ko dito. Hanapan ng butas yung proof nyo. Parang ako yung opposing counsel. Kayo yung counsel for the plaintiff. Tapos magbibigay kayo ng argument kay judge. Judge, ganito siya. Meron ako mga proof. Ang trabaho ko, hanapan ng butas yung proof niyong ibibigay. Now, you might say in your proof, okay, I will choose capital N to be any natural number such that 1 over capital N is smaller than epsilon. But I will raise an objection. Your Honor, hindi tayo nakakasigurado na may natural number N ng 1 over N ay mas maliit kay epsilon. So ano yung isasagot niyo sa akin? Isang tanong ko, meron ba nag-exist na natural number ng 1 over capital N ay less than kay epsilon? Si epsilon nga, super liit na niyan eh. Makaka-sure ka ba na makakita ka pa ng capital N na mas maliit yung 1 over capital N kaysa dun sa epsilon na napakaliit na ibibigay ko? Alright? So yun yung hanapin ko sa proof nyo. Can somebody argue na meron? Bakit meron? Bakit sure tayo na meron? Tanggalin ko yung spoiler. Okay, thank you, Jonathan. May sagot na si Jonathan. Somebody who would like to answer live or using microphone? Huwag niyo basahin yung comment ni Jonathan. Or wala na, agree na kayo kay Jonathan. And Jonathan is correct, right? So the only missing part in the proof is to guarantee na kahit ano yung epsilon, laging may n na ang 1 over n ay less than epsilon. Sabi ni Jonathan, Archimedean property yung kasagutan. And he is right. At sinasabi ng Archimedean property, kahit anong epsilon greater than 0, lagi kang may mahanap na natural number, little n nga lang yung ginamit ko ron, pero it doesn't matter. You can just change little n dun sa Archimedean property by capital N. Ang sinasabi niyo lang, laging merong mas maliit na 1 over n kesa kay epsilon, where n is a natural number. And we will cite that in our proof to guarantee na kahit ano pa yung epsilon, laging nag-exist yung natural number n na iyon. And then we're done. We can just write the proof formally. Medyo pabaliktad nga lang ng preliminary analysis. Now, the preliminary analysis is technically not part of the proof. It is like a scratch work that you do na hindi siya kailangang makita dun sa proof. So unless I ask you to specifically write a preliminary analysis or include the preliminary analysis in your work, hindi nyo siya kailangang isama. Pero sayang naman yung effort nyo. Pag mayabang, pwede nyo ipagmayabang sa akin na kaya nyo mag-preliminary analysis, pwede nyo siyang isama, pero hindi required. Okay? Ang advantage ng isinasama siya ay pagka medyo may mali doon sa napili nyong n or something is wrong in your proof, I can go back to your preliminary analysis and trace what happened. If it's a very minor error, then I can give you very little deduction. Compared kung wala kang preliminary analysis na sinubmit, I don't know how do you get with your answers. So wala akong basis to give you more partial credits. So yun yung pros and cons ng pag-include ng PA. Okay. So essentially, we have all the ingredients ready, so we can start cooking the proof. Okay. So again, yung proof and template. Let epsilon be an arbitrary positive number. So you can just say let epsilon be greater than 0. Next sentence, you need to demonstrate the existence of a capital N. Capital N should be a natural number that can guarantee yung inequality dun sa definition. Okay, but we already did all the hard work in finding N. So sitting pretty na dun sa proof, pwede nyo nang sabihin na, okay, take capital N to be any natural number such that capital N is greater than 1 over epsilon. And you should mention, actually, dito sa proof, ginawa niyang parenthetical remark, but I don't want it to be a parenthetical remark because this is very important. Because the question here is really the existence of capital N for any epsilon. So you need to mention that the existence of such a capital N is guaranteed by the Archimedean property. Okay? Now, para saan si capital N, paano niya nag-guarantee yung gusto nating inequality, yun yung susunod na parte ng proof. Okay? But that's easy. That's basically what you did in the PA. So you can say na, yeah, because if I will choose my capital N to be that guy, then for any subscript little n, after capital N, we have the following inequality. And then ganito dapat kayo nagpo-prove, all right? You always start whenever using an inequality or proving an inequality or an equation for that matter, you always start with only one side. Okay? Tapos unti-unti kayong papunta dun sa kabilang side. Okay? So usually we begin with a sub n minus a. So sulat niyo yung absolute value ng a sub n minus a. Ito yan. Try to simplify it and then basically copy what you did in the PA. So ito, na-simplify ng ganito. But again, with assumption that n greater than or equal to capital N, we have 1 over little n is smaller than or equal to 1 over capital N. Okay? And by the choice of capital N that we declared kanina, kasi hindi kailangan siya mag-work sa lahat ng capital N. Kailangan lamang mag-work siya dun sa mga capital N na binigay natin. Alright? So that means 1 over capital N is smaller than epsilon. So now we have established that the absolute value of a sub n minus a is indeed less than epsilon. So by definition, we can conclude that really the limit of 1 over n as n approaches 0 ay equal kay 1 over n as n approaches infinity ay equal kay 0. Actually, I prefer this more. Sulat nyo na lang na 1 over n approaches 0. Mas maiksi kasi siya. Ano? So, sa kaulaan ng konsepto ng limit. Kasi convergence naman yung gusto ko ritong i-emphasize. Alright? So, 1 over n converges to 0. But if you want the limit notation, then that's fine. All right, any questions? Easy ba? Ganito yung ginawa niya sa 38, di ba? So, there's nothing new here. Of course, mas magiging mahirap yan kapag mas komplikado yung formula para dun sa sequence. But we will not deal with those types of things. Nagawa nyo na yun sa Math 30 series, alright? So, hindi ko na kayo kukulitin about complicated sequences, okay? Sige, let's have a 2-minute health break. Stretching muna tayo, okay? Higop muna kayo ng kape or kung ano man yung meron kayo dyan, milk tea or whatnot. Parang kakaiba, no? Nag-declare na yung pag-asa na nag-start na yung dry season. Of course, ramdam na natin yung init. Pero kakaiba ngayon ay medyo makulimlim. Parang nananadya yung panahon. Ano? Pinapabulaanan si pag-asa. Pero yeah, feel mo na summer na. So may mga plans na ba kayo para sa summer? Or ACADS talaga? Malapit na yung break natin, di ba? So we have a reading break. April, ano nga ba? April 2, right? Tapos after the reading break ay Holy Week pa. So 2 weeks na naman tayong bakasyon. Kayo pala bakasyon. Hindi ko alam kung bakasyon ako or maraming trabaho. Titingnan ko pa. But of course, that's time for us to meditate, rest, and recharge for the last hurrah ng semester. Okay, so mabigat para sa atin yung huli ng SEM kasi nandiyan na yung nagkukumpulan. Doon na nag-accumulate yung mga works, yung mga kailangang ipasa. Oh, by the way, dun pala sa mga nagtatanong, alam ko na yung date nung job fair. Copy paste ko dun sa chat. April 11 yung job fair. So if you guys are interested. Okay, nandun sa chat. Bakit ganun? Kulay black yung font. Dapat white siya. Anyway. So April 11, 2022, IMSP Job Fair. Exclusively for IMSP students. So registration link is given there. It's bit.ly/IMSP Job Fair 2022. That's bit.ly/IMSP Job Fair 2022. Okay. So kung kailangan nyo na maghanap ng trabaho or practicum, okay? Hindi ko alam kung may mga companies na summer job or mid-year job kung nag-offer sila. But you can try this. You can drop by kung wala naman kayong gagawin. Wala namang cost ito sa inyo. Bandwidth lang. Attend kayo. Hindi ko alam yung oras. Baka tatamaan yung 175. Walang specific time, but I imagine this would be a whole day affair. So let's see. Okay. I-paste ko na rin pala yung yung registration links para sa events sa Monday at saka sa 28. Sorry, black yung font. Copy paste kasi from email. Alam mo na, highlight nyo na lang siya para madali nyong mabasa yung text. Pero yun yung dalawang links pa para dun sa ating mga upcoming events. May bonus tayo dun sa March 21 saka sa March 28 para sa problem set number 1. Wala nang bonus yung job fair, right? Ang bonus nyo na doon, makakahanap kayo ng trabaho. Hopefully, all right? Okay. Now, tapos na yung ating health break. Balik na tayo. Example 2.2. In this particular case, we want to prove that the limit of n plus 1 over n as n approaches infinity ay equal kay 1. Okay. Now again, we always start with first making sense of this. Tama ba yung hypothesis na ito yung limit and so on. So what you can do is to try to list down the first few elements of your sequence, okay? And again, the terms in the sequence are ordered. So start ka lagi sa n equals 1 n equals 1, we get what? We get 2 over 1, so that's going to be 2. Tapos, n equals 2, we get 3 over 2, 4 over 3, 5 over 4, and so on. Okay? Pag nagpahanap ako sa inyo ng limit, tapos hindi pa natin nadidiscuss yung mga limit theorems, so pwedeng ganito, intuitive lang yung analysis. Okay? So 2 is 2, then 1.5, then this is 1.3 bar, this is 1.25, and so on. So if you will, kung hindi clear, using the first few terms, dilisan nyo pa yung mga natitira. So damihan nyo pa hanggang makita nyo kung saan siya patungo habang lumalaki si Ed. But of course, you can also analyze the formula itself. N plus 1 over n. Pwede mong gawin yung long division. Pwede mo itong masulat as 1 plus 1 over n. Tapos yun yung i-analyze mo, yung 1 plus 1 over n. So as n increases without bounds, we know that 1 over n will essentially be 0 or a very small number. 1 plus a very small number, we know that that will accumulate at 1. Kaya mukhang totoo yung sinabi ng statement na ang limit ng n plus 1 over n ay equal kay 1. Okay? So now, since we are at least convinced na, okay, mukhang tama yung statement, then pwede na tayong pumunta sa preliminary analysis. The purpose again of the preliminary analysis is to give us the capital N that we need for the proof. Okay? So parang ito yung paghihiwa. Pag nagluluto kayo, ito, maghihiwa-hiwa muna tayo bago tayo mag-start na magluto. Alright? So ano yung sa preliminary analysis? We want to find a capital N such that for all little n's greater than or equal to that capital N, totoo yung inequality dun sa definition ng limit. Okay? So start ka sa a sub n minus a. Tapos simplify. Charan! Tapos maging ganito siya. Oops, ganito na naman, 1 over n. Pero luckily, we already dealt with 1 over n before. Alam ko na kapag 1 over n, gusto ko yang i-relate kay 1 over capital N or something involving 1 over capital, something involving capital N. Pero the only source of the relation between little n and capital N is this part of the assumption that we are only looking for sufficiently large little n's. How large? They should be larger than capital N. All right? So kaya mula rito, pwede kong masabi na yung 1 over little n ay less than or equal kay 1 over capital N. Okay? And then again, here, nakita ko na yung criteria. I can't just force the issue that 1 over capital N is less than epsilon. Because if I will be able to do that, then by transitivity, 1 over little n will be less than epsilon as desired. Okay? So yon. Tapos again, may lagi ba may nag-exist ba na na capital N, na natural number, such that 1 over capital N is less than epsilon? Thank you, Archimedean principle, meron. Okay? So that's what we'll choose. We'll choose capital N to be any number greater than 1 over epsilon. Because again, we'll be forcing this issue. So that means we will choose capital N to be anything that is smaller than, smaller ba? No. We'll choose capital N to be anything larger 1 over epsilon. Okay? Tapos formal proof. Okay? Again, template. Start with an epsilon. Start with a challenge. So you'll say, let epsilon be greater than 0. Okay? Then, by the Archimedean property, there will exist a natural number capital N such that capital N is larger than 1 over epsilon. Or actually, pwede nyo nga itong palitan. Gamitin nyo na yung nandun sa Archimedean principle talaga. Sabihin nyo na lang such that 1 over capital N is smaller than that very small epsilon. Okay? Anyway, mas natural naman ito. Ito yung gagamitin natin later. Okay? Now, mention the assumption that we are only dealing with sufficiently large little n's. Okay? Na kapag ka yung little n, yung subscript, dun sa sequence, ay mas malaki na dun sa capital N na pinili natin kanina. Paano natin pinili yung capital N? It is any natural number na mas maliit na yung 1 over capital N kaysa kay epsilon, then we will show that we have attained the desired inequality. Since I want to prove the inequality, hindi ko siya gagawin na high school style, na mag-start ako dun sa inequality na gusto kong ipakita para ma-prove siya yung sarili niya. Mag-o-object ako pag gandun yung proof nyo. Alright? So gusto kong gawin nyo, mag-start kayo sa isang side ng inequality, ipakita nyo na makukuha nyo yung kabilang side ng inequality. Alright? So we start with the with the left-hand side of the inequality we desire. Okay, a sub n minus a, absolute value. Simplify this guy, which is basically what you did in the preliminary analysis. So you have this, magiging ganito siya, absolute value niya ito. Tapos we know that we are dealing with little n's that are greater than or equal to capital N. So 1 over little n is sure to be less than or equal to 1 over capital N. Okay? But this guy is by our choice of epsilon. Our choice of capital N. Kasi earlier, we have said na pag binigyan mo ko ng epsilon, ang sagot ko sa'yo na capital N ay kahit anong natural number na ang 1 over n ay mas maliit kay epsilon, the existence of which is guaranteed by the Archimedean property. Okay? So we're sure that 1 over n is definitely less than epsilon. So what do we have now? We have absolute value of a sub n minus L less than epsilon. That's sufficient to conclude that that n plus 1 all over n converges to 1. End of proof. Right? So yun yung illustration paano gumamit ng definition pag-prove ng limit ng sequence. Okay? I know you already did a bunch of these in Math 38, pero hindi na ito yung magiging focus. Talagang ano natin siya, refresher lang. Paano gamitin yung definition? Because later we'll be proving statements about or theorems involving the limit of sequences, and the proof will generally make use of the definition. So kaya gusto kong i-refresh kayo kung paano nagagamit yung definition sa proving. Okay? Now, if you want to practice more, there are 3 exercises here for you to try to answer. And puprove nyo lang naman na totoo yung mga convergence statements na yan. Okay? I think problems 1 and 2 will be straightforward as the last 2 examples that we have. Siguro medyo sa number 3, I'm not sure, pero siguro may konting manipulation na kailangan gawin dito. But I don't think it's very hard. So kayang-kaya na yung part 3. Okay. So try this out. Let me know on Tuesday if you encountered any problem writing the proofs for this. But I know you will be focusing on the problem set. So yeah, if you have extra time, try to answer these exercises. Then I want to end by talking about divergence. Okay. So kapag ang isang sequence ay may limit, or nagko-converge sa isang particular number. So, ibig sabihin, ang tawag natin sa sequence na yun ay convergent. So, we say that that sequence is a convergent sequence. Now, kapag hindi naman siya nagko-converge sa kahit anong real number, kasi posible rin naman na walang convergence. Okay? Walang specific number na ina-approach yung mga nandun sa dulo ng listahan, then we say that that sequence does not converge. Okay? Or to simplify the language, when we say a sequence that does not, we say that the sequence that does not converge, diverge. Okay, or we call it a divergent sequence. And then specifically, we say that the limit of a sub n is not equal to a if and only if the negation of the statement in the definition of convergence is true. So, i-negate lang natin yan carefully at yung makukuha nating statement. Si A ay hindi limit ni A sub n kapag we can find an epsilon greater than 0 such that for any capital N that is a natural number, there exists a little n such that A sub n minus A is greater than or equal to epsilon sub 0. Okay? Essentially, this whole statement is telling us na kapag si A sub n ay hindi magko-converge kay A kapag ka merong isang epsilon, kahit isang epsilon lamang, na laging merong high order terms or merong high subscript term na ang distance mula kay A ay mas malaki kay epsilon sub 0. So kapag ka meron ka nakita na element na malaki yung subscript na ang distance mula kay A ay greater than or equal to an epsilon greater than 0. Okay? So yun yung idea. So merong merong isang element dun sa dulo ng listahan na malayo pa mula kay A. All right? And you should be able to do this for all capital N's. Okay? Now, let's see how this figures out, okay? So, example. Consider natin yung sequence na -1 to the power n. If you write the first few elements of this sequence, you get this. Nawala yung braces. So, -1, comma 1, comma -1, comma 1, and so on. Okay? Now, our claim is that the limit is not equal to 1. So, para mapakita to, kailangan ko magbigay ng epsilon sub 0. Such that dun sa epsilon sub 0 na yon, makakahanap ako ng mga elements dun sa dulo ng listahan na ang A sub n ay hindi malapit kay A. Gaano kalapit? It is epsilon sub 0 units away. All right? Now, what the text did is to consider epsilon sub 0 equals 1. So ang goal niya ipakita na merong mga elements dun sa listahan na mas malayo kay 1. In particular, ang distance away from the supposed limit ay more than 1. Okay? So yun yung sinasabi nito. Sa lahat ng capital N, kahit saan ka magsimula kay capital N, okay? Lagi tayong may makikita na A sub little n, somewhere here, yung subscript niya ay nandito, na ang distance mula kay 1 ay mas malaki kay epsilon sub 0, which we chose to be equal to 1. Well, where the heck did the lecture notes got epsilon sub 0 equals 1? Well, ano ba yung tinitingnan niya dito? Gusto natin ipakita na yung limit ay hindi equal kay 1. Okay? So titingnan niya, ano yung layo ng mga terms ng sequence mula kay 1. Okay? So, dun sa mga even terms, wala siyang problema kasi 1 yung even term. So, 1 minus the supposed limit 1 equal kay 0. So, malapit na malapit. Okay? Kasi ang distance ay 0. Pero pag nandun ka sa mga odd terms, and the odd terms are everywhere, A sub 1,001, A sub 1,000,001, ang lahat ng value nila ay -1. Gaano kalayo si -1 mula dun sa kiniklaim na limit na 1? It's 2 units. Okay? So essentially, pwede pala kahit anong number na mas maliit kay 2. Alright? Pwede kong piliin na siya ay equal kay 1/2, equal kay 3/2, kay 1/2, or anything basta less than 2. Kasi nga, lagi akong may makikita na odd term, okay? Na ang layo mula dun sa hulang limit na 1 ay more than 1. Then essentially, that is what is done in this proof of divergence. Okay? So, nagpakita ako ng epsilon. Sinabi ko ang epsilon ko ay equal kay 1. Then, we are sure that for any natural number capital N, there is always a little n. Merong isang A sub n with subscript little n na mas malaki kay capital N na totoo itong inequality na ito. Ibig sabihin, malayo yung A sub n mula kay A. Well, kailangan nyo sabihan sino yung A sub n kasi rito existence naman ng little n yung hinahanap natin. So, ang binigay kong ditong little n ay 2 times capital N plus 1. Because I want the odd terms. Okay? Kasi mga odd terms, sila yung malalayo mula kay 1. Kaya nga for any capital N, I am choosing the little n's to be 2n plus 1, which is definitely greater than n. So, satisfied ito. Ito yung pinili ko. So, kapag ka si A sub n, tapos yung subscript niya ay odd, then si A sub n ay magiging equal kay -1. Alright? Tapos minus 1, pinopia lang siya doon. So -1 minus 1, that's -2. Take its absolute value, you get 2. And 2 is definitely greater than or equal to the epsilon that we have declared earlier. Okay, which verifies the inequality in the definition. So therefore, the limit of a sub n is not equal to 1 because there are terms in the tail end of the sequence whose distance from a sub n is greater than the epsilon sub 0 that we have picked. All right. The same thing will happen for a sub n for negative 1. You can show that the limit of the sequence cannot be negative 1. I think a similar argument, except that you will now be picking little n's to be 2 times capital N. Yung mga even naman, yung i-consider nyo. Kasi yung mga even terms, sila yung within more than 1 unit away mula dun sa negative 1. So that's fine. Okay. Tapos, madali ring ipakita na hindi pwedeng maging limit ng ng sequence na to yung kahit anong real number na hindi equal kay plus or minus 1. Okay? So, I'll leave that for to you to think about, okay? Pero siguro dito ko simulan yung lecture next week to give you a detailed explanation bakit yung mga real numbers na hindi equal kay plus or minus 1 ay hindi pwedeng maging limit ng sequence na to. But essentially, since we have no choice for the limit of a sub n, then we can conclude that the sequence does not converge. All right? Or we can say that this is divergent. Well, the problem with this analysis is parang inexhaust natin lahat ng posibleng maging limit ng sequence. Tapos pinrove natin yung impossibility of all those candidates from becoming the limit of the sequence, which is very tedious, okay? Dito madali lang, pero pag komplikado na yung sequence, baka mahirap na na-prove na hindi siya pwedeng magkaroon ng limit. Kasi isa-isahin natin yung mga candidates para maging limit niya bago ma-conclude na divergent yung sequence. Okay? So later, we will establish a divergence criterion to make our lives easier. Okay? Para mas madaling masabi na divergent yung isang sequence. But that's going to be for Tuesday next week. Okay? So do you guys have any questions before we call it a day? Okay, so kung wala na, tigil na natin to. Let's continue it on Tuesday. Until then, please enjoy the weekend. Think about the problem set and yeah, stay safe, everyone. Bye.